Hi, math friends. Today we're looking at our proportional relations and equations study guide. So let's check it out. First, we have to decide if relationships are proportional that are in a table. So we need to remember to do y over x. So for here, we're going to do 88 over 44. And if you're not comfortable with dividing that, go ahead and use your calculator, but you get 2. We also need to do 100 over 50. Now, this is also part of showing your work. Even if you can do this mentally, show the steps for it. And for this one, we're going to say, yes, this is proportional. So we can say, this is proportional. And it also says to the top of the study guide says to circle our final answer, so we'll go ahead and do that. The next one here, we're going to do y over x again. So y value is 50, x value is 10. Divide that, we get 5. Next part, y value is 110, x value is 20. 110 divided by 20, we get 5.5, 5.5. So not the exact same ratio. So for this one, we're going to say no, this is not proportional. Circle my final answer, and we're good. All right, next we have proportional equations. So we have earning $14.50 an hour at a new job. So let's start that. I have $14.50 per hour, meaning for 1 hour. Remember, the units are important. I'm going to use the dollar sign in hours here. Equals, how much do you make if you work for 20 hours? Well, 20 hours is going to go here. Hours is across from hours. How much do we make? We don't know yet. So we're going to multiply diagonally. We're doing our cross products here. 20 times 14.5. This is 290 for our equation. Equals, use a different color here. 1 times x is 1x. 1x is the same as x, simplifies to that. So we get 290 as our answer, and that's money, so we're going to put $290. Third one here, a person who weighs 100 pounds on Earth would weigh 38 pounds on Mars. Set a proportion and solve to find out how much a child who weighs 60 pounds on Earth would weigh on Mars. So we have two things. We have the weight on Earth, weight on Mars. I'm going to make my first proportion with what we know, 100 pounds on Earth. I'm going to use E for that. And 38 pounds on Mars. All right. For the other one, we know that there's 60 pounds on Earth, so we'll put that straight across from the pounds on Earth. And we got X pounds on Mars. All right. Let's do our cross products. I get 100x equals, what's our other cross product? 38 times 60. I get 2,280. And we're going to go ahead and solve that then. Divide by 100. Divide by 100. I get 22.8. So then our final answer would be they would weigh 22.8 pounds on Mars. And circle my final answer as well. There we go. All right, next one. So the person Yusuf ran 20 kilometers. How many miles did he run? All right, so we know that he ran 20 kilometers. We don't know how many miles, but we do have the rate here. I have 1 kilometer is the same as 0.62 miles. Okay, now set up check to make sure you set that up right. Miles is directly across from miles in our proportion, and kilometers across from kilometers. So we're going to go ahead and multiply 0.62 times 20. We get 12.4 equals x times 1 is 1x. Well, as we saw before, 1 times anything is itself. So we get 12.4 here. So our final answer is going to be he ran 12.4 miles. Another table here. It says this shows the problem math problems Maeva solves over time. The two quantities vary directly. Determine the unit rate of math problems solved per minute. So we can do what we did before, where we divide y over x. 4 divided by 5, I get 0.8. The problem tells us that this varies directly, but we're just going to check that. 20 divided by 25, and we do get 0.8 again. So, and we want to know the unit rate of math problems solved per minute. So here's us showing our work. So then we can say she solves 0.8 problems per minute. Remember, that's our unit rate, 0.8 problems per minute. We want to have the words there too. Go ahead and circle my final answer, and we're good there. All right, let's go ahead and check out this one. Parking in a parking garage, they charge this much. So we're going to complete this table. $8 for a half hour. Well, if we're being clever, that'd be 16 for a whole hour. For another half hour, it'd be another 8, and so on. So let's make sure that we fill that in properly. What is the garage's unit rate for parking? This one is actually in the table. It's right here, where we have per 1. Unit rate is always per 1. So now we're going to write that. It is $16 per hour. Circle my final answer for that. If you park 30 hours, how much are you charged? Well, I know that it's $16 for 1 hour. So 30 hours, we don't know. We can set it up like this. If you have a different way of doing it, make sure that you show your work for it, because there are a couple ways to do this one. So we're going to multiply 16 times 30. That's 480. And 1 times x is 1x. So 1x is just x. It looks like it's going to cost $480 to park for 30 hours, so do not park here for very long. That would not be a fun bill to try to pay. Next one, that says Raphael was charged $55 for parking. How many hours did he park in the garage? I'm looking at my table here. 55 is really close to 56, which is close to 3.5 hours. So let's try that out. I have $16 for 1 hour, and he paid 55. We don't know the exact number of hours. All right, so now let's do our cross products. 16x and 1 times 55, I get 55. So then we'll divide by 16. You're seeing here, if you can set up a proportion for things, you can solve a lot of problems a lot more logically and not have to guess with what do I multiply, what do I divide, what do I do this or that with. All right. If we round to the nearest hundredths place, it's going to be 3.44 hours. All right. A recent survey on candy found that 5 out of 6 students like Takis. I think this means like snacks. That's okay though. Complete the table, show our work. So if 5 out of 6 like Takis, it will be 5 out of 6. If 5 out of 6 or if 24 of them, but it's 5 out of 6, huh? So 5 out of 6 of 24. So if we do that, we get 20. 5 out of 6 again for 360. Number 360 is 360 over 1. So I'm getting 300. Okay. And lastly, 5 out of 6 for 600. Well, that's a little bit simpler. So 600, 5/6 of that would be 500. It does say show all work. So if we want to show our work for that, we're going to multiply here. If you do that in your head, that's fine. If you do it on a calculator, that's fine, but we're going to show the numbers that we're multiplying here. All right, very last one here on this study guide. So we got a plot first. It says this table shows the price per ounce of cheese at a grocery store. The price varies directly with the weight. Plot the data from the table. So let's plot this first. 4 ounces of cheese is $2. So 4 ounces of cheese is $2. Then I get 5 ounces for $2.50. So 5, $2.50. 2 ounces for $1. And I get 14 for 7. Now if I use my ruler on my paper, this should end up nice and straight here. I'm going to go ahead and use this drawing tool here. And it looks good. All right, so part B, explain what the point of the origin represents. Remember that the origin means 0, 0, right? So what does that mean? Well, 0 is X. So 0 means cheese in ounces. So I'm going to say this means that 0 ounces of cheese, and the second part is the price, will cost $0. And that makes sense because if you're not buying anything, it shouldn't cost anything. Part C, determine the unit rate for the situation, show all work. So we know that it's proportional, so let's pick unit rate to do here. So I'm going to do y over x, 2 divided by 4. I get 0.5. So we're going to say 0.5, that means 50 cents. So this is 50 cents per ounce of cheese. Remember, unit rate is per 1. All right, so good luck working from that. Pause, rewind, go over it as you need to, ask good questions in class, and good luck to you.